now we're going to look at lab 4 here, which is our voltage follower. Pull that up, and should notice a little bit of a difference here compared to the other ones we've done right now, which I just gone over in the lecture. Now we use actually a Darlington pair. Now, one of the things they call out the directions, right, is assume that it's but in this case, we can know we have it dead on, right? 100 beta on this and 100 beta on this, multiply that out, and yeah, what do we get? One with 4 zeros behind it, so 10,000, and I'm pretty sure that's what it calls out for. So a lot of this stuff is, you're going to do some calculations, so we do have some good material in there for that. I posted up, with the recent lecture and whatnot, what our prime is and that kind of thing. And then we get to actually notice what the Darlington pair does. And I know one of the things that it did call out for was go ahead and disconnect the AC sources here, right, to verify that your circuit is biased correctly. It's like, okay, will it, oh, no one here, get rid of that. Okay, so if it's biased correctly, you should have a good smooth current flow going on, right? And in this case, we do, right? So we know we've got this transistor's activated, this transistor's activated. You can tell, we get the base tied to ground here, so we got the negative feedback activating this guy, right, coming in, swinging around, and going back to ground. So we do have current flow. So that's a way to quickly check and and throughout all these experiments, when we move forward, it's like, how do you make sure that we are DC? Again, you have to be DC biased, right? So make sure that your circuit is turned on. So let's go ahead and end that part. And now we'll reconnect our AC again and find out what our Darlington pair can do for us. So that's the hookup for it. And I have you go through and, of course, we're not using a transistor curve tracer or a beta checker. We can pretty much dead on have our beta values of 100 for each of them, right? Just check the values of your transistor, make sure that they are that. Excuse me. So moving on to that, now what they want us to do is go ahead and use a 1 kilohertz sine wave and apply a signal source and adjust it to achieve a source voltage of 2 volts peak to peak. Well, in this case, we'll go ahead and actually, all right, 2 volts peak to peak. Is it that? Let's find out, shall we? Oh, no, I went too high, didn't I? So let's bring that down, my bad. So 2 volts peak to peak. Looking at the input right there, right? See that? So looking at our scope output. So now we'll go ahead and stop observing that. So now we got 2 volts peak to peak with a 1 kilohertz sine wave coming in. We see that our DC is biasing. You notice there is some strange thing going on with the current flow. It seems to start and stop, doesn't it? And then we go ahead and look at our output in this case. See what we're getting out. Now, and they ask you to go through and so we may have a source voltage of 2 volts peak to peak, right? For example, to the left of RS, which we did indeed check. And you can go ahead and check that on yours as well. Now it wants you to go through and measure the peak to peak voltages at the source, the base, and the load, right? And we can do that because basically all you have to do is go through and it's like, well, in this case, here's our load. Okay, first thing we did look at. So if we take that back off, stop looking at that, look at, and here's a highlight, and there's our source, right? So we know, okay, so that's what we're putting in. You can check at get your base here and observe as we run. It's like, what do you have going on in that case? Shh. You know, and there's me with the source and the at the base in this case. So if I want to get rid of the source, now I can see what my base is there. And you can also look at it at the base of the other one of the Darlington pair, right? We can even compare the two. Okay, so that would be looking at both bases with the amplitudes like that to give us our waveform. Stop looking, back it up, back it up. Oh, that's my circuit overall. So yeah, I mean, ideally, what are you looking for really? You're always, you know, looking at your source, looking and comparing it to your output. So in this case, what my source is green, my output here is blue, and we can compare the two signals overall, right? Excuse me. So we have to go through and verify some things. I feel that basically, I mean, so you know, this one's pretty straightforward. We're not doing anything too fancy, but I mean, it does introduce us to more of the AC, which I was hoping for, get us used to setting up, you know, our Darlington pair in this case, and change some values and vary things and see what our overall responses are, right? You can go back and look. We can check our Bode plot at these points and see what we have. You know, you can even check it, like I say, the various points and see, okay, what our Bode plot is. So you see what your frequency response, and I mean, see how it changes the colors with all of this. So really, I mean, we have several things happening. And now I've got, there's my swings at source, the two bases before, and the final output there. You know, we can compare and we can see that that they are more or less in phase, that kind of thing. So if anybody has any questions about this particular circuit, you know, shoot me a line and everything. We'll go over things, you know, these vary as we go along and see what happens to your changes overall, right? And of course, the capacitor, right? It's expected. Let's see, set it back to 470 here. I feel this lab was pretty straightforward, and that way you get your nice smooth outputs there with your Bode responses and everything. So you should be able to run through this. Typical Darlington pair, cascaded, right? Cascaded amplifier. So you're using two transistors like that. And you can see, you know, check and make sure that both of them are set to your ideal of 100 in this case. And they are. And I think that's really about everything with this lab. Go through and, I mean, as far as the questions are concerned, right, with the results of this exercise have been considerably different. If the load had been 10 times larger, well, the great thing about this, it's like you can actually, you can change that on the fly and even see. And it's like, well, what would happen if you increased your load, right? When at 10 times larger. So if it was a 220, what would you have? A 2.2, very touchy. 2.2, and then you can actually see, you know, I think it's a great thing about the simulator. So you can actually see it as you go along. You should be able to answer that one through, right? And then like a hypothetical, if the 22K source had been directly connected to the 220 load without the follower in between, what would be the load voltage? Number 3, well, you know, how do the total harmonic distortion levels of the follower compare to those of the swamped common emitter? Now, that is one thing I will, oh, good Lord. No, what did I do? Yeah, that's what happens when I come through circuits like that. Awesome. Somehow I have deleted my resistor. Not sure how I did that, but let's go back in. But I mean, I will point out as far as like you notice there was no clipping in this case, right? You didn't have anything affecting your rise and run of the output at all. Much smoother overall. It's very stable amplifier, if you will. I mean, if we look at that, right? No clipping or anything like that. I mean, we could vary some components and even see. And of course, you can go through, like I was saying, and even compare what your Bode plot would be to see if this thing is stable. And I mean, look at it, it's nice and smooth. So, and you can vary components even, and of course, and look at that as well and see how this amplifier holds up for hypothetical. And then and how would the circuit parameters change if a Darlington pair had not been used? Well, it's a very similar circuit to the others before. Basically, what did we do? We still have the same, you got the negative supply in the emitter here, positive supply in the collector side, right? The only difference we really have is we've added this one transistor in tandem with that. And you'll notice that compared to like the Swamp CE or even the CE, that this circuit is far more stable. Excuse me, as far as being affected by negative feedback, right? I mean, you can still see it's occurring, right? Because that's, I mean, essentially as we watch, see how the current flow goes through here, start and stop on the alternations. So as it fluctuates through, we do know that there is negative feedback occurring in this case, but the way it handles that, look at that, the stability factor is much greater as we add that in there. So the one transistor cascaded into the other adds a large degree of stability to the overall amplifier. And again, I'll pause it. I'll go ahead and I'll save this if we need to review or anything like that, but that is my pair comparison for everybody. If we do have any questions, or Darlington pair, the voltage follower. That's about all I have for this one. Okay. Alrighty. Stop that, and we shall stop recording.